we can divide by -2. So y equals -4 divided by -2 would be 2, followed by x, and 8 divided by -2 would be -4. Mx plus b again, we can solve for the slope. M equals 2, or 2 over 1, and b is -4. Looking at the two equations, we'll have the same slope, so we'll have parallel lines, but they'll start at different points on the y-axis. The first equation starts at 6, and the slope is 2 over 1, so we'll go up 2 spots and to the right 1 spot. The second equation starts at -4, and the same slope, up 2 and over 1. These equations again are parallel, so they will not cross. Second equations and last equations for the section. 3x plus 4y equals 12. And the second equation, 2x plus 4y equals 8. Solve this equation if you wanted to. You could put each of these equations in mx plus b form and graph from there. Another way to graph, if you remember, is the x and y intercepts. You can plug zeros in for x and y to find the intercepts. Taking the first equation, if we plug a 0 in for y, the y's will cancel, so we'll have 3x equals 12. Solving for x, we can divide by 3, and x would equal 4. Taking the same equation, but now we'll put a 0 in for the x value. Crossing off the x's, we'll be left with 4y equals 12. And dividing by 4, we'll have y equals 3. So the first equation, we have two intercepts, x equals 4 and y equals 3. We can graph those in just a minute. The second equation, if we put a 0 in for y, we'll have 2x equals 8. Dividing by 2, we'll have x equals 4. And the second equation again, if we put a 0 for x, we'll have 4y equals 8. Divided by 4, we'll have y equals 2. So we can use the x and y intercepts for each equation to graph. The first equation, x was equal to 4. On the x-axis, we can put a point at x equals 4, and y equals 3. We can put a point at y equals 3. Connecting those, we'll get the first line. The second line, we also have x equals 4, the same point we had before, but this time we have y equals 2, which will be 1 spot lower. Connecting those 2 points, we'll have the second line, and we'll have the graph for the equations. Title of the first section today is It a Solution? In this section, we'll take a point and see if it's a solution for both equations. First point is 2, 3, and the two equations, y equals x plus 1, and the second equation, y equals 2x minus 1. Again, we'll take this point, plug it in, see if it works for both equations. If you remember, all points are x comma y. First number is x, second number is y. So we'll take a 2, plug it in for each x, and a 3, plug it in for each y. The first equation, y equals x plus 1. In place of y, we can put 3 equals x plus 1. Instead of x, we can put 2, which would be 2 plus 1. Simplifying, 2 plus 1 would be 3, and we'll have 3 equals 3, which works for that equation. Second equation, y equals 2x minus 1. Instead of y, we'll put 3 equals 2 times x, but instead of x, we'll substitute a 2 minus 1. Simplifying, we'll multiply first and subtract second. 2 times 2 would be 4, 4 minus 1. Simplifying, 4 minus 1 would be 3. So 3 equals 3, which is a true statement. Since the point is true or works for both equations, the answer to the question, is it a solution? The answer would be yes. If it works for both equations, the answer is yes. If it does not work for one or both equations, it would be a no. Second question, and last question for the section. First point is 1 comma 2. And the first equation, y equals 3x minus 1. And the second equation, y equals 4x plus 1. Again, to solve this, we'll take the points 1 comma 2, which are again x and y, plug it into each equation. The first equation, y is equal to 2, 3 times x, or 3 times 1, minus 1. Simplifying, 3 times 1 would be 3, and 3 minus 1 would be 2. So 2 equals 2, which works for the first equation. The second equation, y is equal to 2, 4 times x, or 4 times 1, plus 1. 2 equals, 4 times 1 would be 4. Adding 1 to that would be 5. So we'll have 2 equals 5, which is a false statement. If you have a false statement, it means the point does not work for the second equation, and the answer to the question, is it a solution, would be no. Title of the last section today is Solving by Substitution. In this section, we'll solve by substitution to solve for x and y. First two equations, y equals 4x minus 8. And the second equation, y equals 2x plus 10. To solve by substitution, we'll substitute or replace one of the variables. In the first equation, we have 4x, y equals 4x minus 8. And the second equation, y equals 2x plus 10. If we know what y is equal to 2x plus 10. We don't know the number for y, but we have an expression for that. We can substitute and replace for the other y. So y is equal to 2x plus 10, which means we can replace the other y with 2x plus 10. Rewriting the first equation, instead of y, again we'll substitute or replace with 2x plus 10, and equals the second part of the equation, which is 4x minus 8. By using substitution, the y's are now out of the equation, and we can solve for x. Solve this equation for x. We'll put all the x's on one side of the equation. If we have a positive 4x, we can subtract 4x from both sides. 2x minus 4x would be negative 2x plus 10 equals 4x minus 4x would cancel, and we're left with negative 8. Solving again for x, moving a positive 10 to the opposite side. We can do the opposite by subtracting 10. So we'll be left with negative 2x equals, the 10's cancel. Negative 8 minus 10 would be negative 18. When you have these same signs, we'll add those and keep the sign negative. And last part, we can divide by negative 2. And we get our first answer, x equals negative 18 divided by negative 2 would be positive 9. So x equals 9. Keep in mind this is the first answer. We know x is equal to 9. Second part, we need to solve for y. To do that, you can go back to either the first two equations. If we take the second equation, which was y equals 2x plus 10. Once we know x is equal to 9, we can substitute or replace a 9 in for x. So we'll have y equals 2 times x, which is 9, plus 10. Simplifying, we'll multiply before we add. 2 times 9 would be 18, and adding 10 would be 28. So our two answers, x equals 9, y equals 28. You can also write this as a point, x comma y. X would be 9, y is 28. So we'll have the point 9 comma 28, which is where these lines would cross if we did graph them. But the solution is 9 comma 28. Second equations and last equations for the section. First equation, we have c inside parentheses n, which stands for c of n, equals negative 3n minus 6. And the second equation, again we have c within inside parentheses, which is a notation for c of n, equals n minus 4. C parentheses n, or c of n, is similar to y. It's basically a variable that we can solve for. So we have two variables. We have the n, and we also have c of n. Solving by substitution again, we can take the second equation, c of n equals n minus 4, and we can take the n minus 4 and substitute for the c of n. And again, instead of c of n, we can rewrite using n minus 4, and equals the second part of the equation, negative 3n minus 6. By substituting n minus 4, now we have a single variable n that we can solve for to get the answers to the equation. Solving this question, we want to combine like terms or move all the variables to one side. Opposite of minus 3n would be add 3n. N plus 3n would be 4n. Minus 4 equals. Minus 3n plus 3n would cancel, and equals negative 6. Solving from here, we can add 4 to both sides to isolate the variable n. So we'll have 4n equals negative 6 plus 4. Negative 6 plus 4 would be negative 2. Different signs will subtract. 6, the bigger number, will keep the negative. And last part, to solve for n, to get rid of the 4 that we're multiplying by, you can divide by 4 on both sides. And n equals negative 2 over 4 would be a fraction. If you reduce the fraction by dividing by 2, n equals negative 1/2. And again, keep in mind this is one answer to the question, n equals. Looking back at the original equations, we still want to solve for the second variable, c of n, or c parentheses n. You can use either of the first two equations to solve. If we take the second equation, which is c of n, equals n minus 4. And again, if n is negative 1/2, we can plug a negative 1/2 in for n. So we'll have c of n equals negative 1/2 minus 4. To subtract a fraction and a number, you can make both the numbers fractions. Negative 4 would be negative 4 over 1, and we can get common denominators to subtract. The common denominator between 1 and 2 would be 2, so negative 1/2 would stay the same. Negative 4 over 1, we can multiply the numerator and denominator by 2, so we'll have negative 8 over 2. And to get our answer, C of n equals negative 1/2 minus 8 over 2. Negative 1 minus 8 would be negative 9 over 2. So our two answers, n equals negative 1/2 and C of n equals negative 9 over 2. Title of the first section today is Review, Solving by Substitution. In this section, we'll solve two equations and we'll use substitution to solve. First two equations, y equals 3x minus 4, and second equation, y equals 2x plus 2. Again, to solve by substitution, we'll replace one of the variables and solve for the other variable. The second equation, we have y equals 2x plus 2. Since that is equal to y, we can replace or substitute that in for the other y. So rewriting the first equation in place of y, though, we'll substitute or replace 2x plus 2 and equals the other side, which is 3x minus 4. Now we have one equation with one variable that we can solve. To get x by itself, we move all the variables to one side. The opposite of positive 3x would be minus 3x on both sides. 2x minus 3x would be negative x, or negative 1x, plus 2 equals 3x's would cancel, and we'll be left with negative 4. Solving for x, the opposite of adding 2 would be subtracting 2. So we'll have negative x equals negative 4 minus 2 would be negative 6. And to solve for x, if we have a negative x or negative 1x, to make it a positive number, we can divide by negative 1. So the negatives will cancel, and we'll get our answer x equals negative 6 divided by negative 1 would be positive 6. Keep in mind this is the first answer, x equals 6. To get our second answer, we can plug this into either of the first two equations to solve for y. If we take the first equation, which was y equals 3x minus 4, now we know x is 6, we can plug a 6 in for x and solve for y. 3 times x would be 3 times 6 minus 4. Y equals, multiplying first, 3 times 6 would be 18. 18 minus 4, and the answer would be 14. So we have two answers, x equals 6 and y equals 14. If you want to, you could write this as a single point, x comma y, which would be 6 comma 14. This point represents the solution, or where the graphs would cross if you graph the equations. Title of the last section today is More, Substitution, Questions. In this section, we'll continue to solve equations using substitution. First two equations, y equals x minus 2. And the second equation, 2x plus 2y equals 4. Solving by substitution. If you look at the second equation, this one we cannot substitute in for x or y because it's not solved for x or y. But the first equation, we have y equals x minus 2. If y is equal to x minus 2, that means we can replace that in for the y in the second equation. So rewriting the second equation, we'll have 2x plus 2y, but instead of y, we can put parentheses and we'll substitute in or replace it with x minus 2 and equals 4 from the equation. Solving from here, 2x would stay the same, plus 2 times the parentheses. If you remember, we'll use distributive property, multiplying each number, each term by 2. 2 times x would be 2x, and 2 times a negative 2 would be negative 4, equals 4. Combining like terms, 2x plus 2x would be 4x, minus 4 equals 4. Solving for x, we can add 4 to both sides, and we'll have 4x equals 4 plus 4 would be 8. And last step, to get our first answer, we can divide by 4. So our first answer, x equals 2. Again, keep in mind this is our first answer. This is one variable. We still need to figure out the second variable, which is y. Plugging it back in, you can use either equation. The easiest equation to use in this case will be the first one, since we already have y by itself. So y equals x minus 2. But again, instead of x, since we solved for x, we can plug a 2 in for x. And we'll have y equals 2 minus 2 would be 0. So our two answers, x equals 2, y equals 0. And again, when you have x and y, you can write that as a point. X is 2, y is 0, so the point would be 2, 0. Second question and last question for the section. First equation, 2x plus 3y equals 14. And the second equation, 4x plus 2y equals 12. Solving these two equations by substitution. At the beginning of the question, each equation is not solved for y, so we cannot substitute in at the beginning. But what we can do is take one of these equations and solve for either x or y. In this case, if we subtract 4x on both sides, we can start to solve for y to get y by itself. So 2y would come down. Putting x first, since we cannot combine it with 12, we'll have negative 4x plus 12. And again, solving for y to get y by itself, we can get rid of the 2 in front. It's multiplying by 2, so we can divide by 2. And we'll get an equation we can use for substitution, which would be y equals, dividing each number by 2. Negative 4 divided by 2 would be negative 2x, and 12 divided by 2 would be 6. So we have an equation that we can use for substitution, y equals negative 2x plus 6. When we substitute this, we'll take the negative 2x plus 6 and plug that into an equation to solve for y. When we plug it in, we want to use a different equation that we have not used yet. Since we use the second equation to solve, we'll take this number or this expression and plug it into the y for the first equation, which again is the equation we have not used yet. So rewriting the first equation, we'll have 2x plus 3y. But again, instead of y, we'll plug in negative 2x plus 6. and equals 14. Solving from here, the 2x would stay the same, and when we have a number outside the parentheses, we can use distributive property to simplify. 3 times a negative 2x would be negative or minus 6x, and 3 times 6 would be plus 18, equals 14. Again, continuing to solve, we can combine like terms. 2x minus 6x would be negative 4x, plus 18 equals 14. Solving from here, to get x by itself, we can get rid of the plus 18 by subtracting 18 on both sides. So we'll have negative 4x equals 14 minus 18 would be negative 4. And last step, we can divide by negative 4. And we'll get our first answer, x equals positive 1. Again, keep in mind this is one answer, x equals 1. We still need to plug it back in to solve for y. Solving for y, you can use any of the first two equations to solve. We can also use the equation that we simplified to use for substitution. If we use this equation, we'll have y equals negative 2x, but instead of x, we can replace that with 1 and plus 6. So y equals negative 2 times 1 would be negative 2, plus 6. Negative 2 plus 6 would be 4. So we'll have our second answer, y equals 4. And again, you could write this as a point, x comma y, which should be 1 comma 4. This point again represents these two equations would cross at 1 comma 4. Title of the first section today is Solve by Elimination using subtraction. In this section, we'll take two equations and solve by using elimination, and we'll use subtraction to solve. First two equations, 3x plus 4y equals 18. And the second equation, 3x plus 3y equals 15. To solve using elimination, we want to eliminate either the x or the y variable. The ones with the same coefficient we can eliminate. The y's have different coefficients or different numbers in front, but since the x's have the same number, we can eliminate the x's by subtraction. Putting parentheses around the second equation and putting a minus sign outside the parentheses will subtract the first equation from the second equation. 3x minus 3x would cancel. 4y minus 3y would be 1y or just y. And 18 minus 15 would be 3. So using subtraction, we can eliminate or cross off the x's. Simplifying, we actually have our answer. Our first answer would be y equals 3. Keep in mind we want to solve for two answers. Y equals 3, we want to solve for x. To solve for x, you can take either of the first two original equations and we'll plug a 3 in for the y. If we rewrite the first equation, 3x plus 4y, but instead of y, we can plug a 3 in, equals 18. So again, taking the first equation,